All right, this is section 4.7, finishing up piecewise functions and adding step functions, which is a form of a piecewise. Tonight's homework will be page 223, 23 through 36 all. All right, so the first thing I'm going to do is I'm going to name both of my lines in the piecewise function. After I name them, I need to write the equation of the line for each equation. So Ryan, what do I need in order to write the equation of the line?
Well, for the equation, you need the slope and the y-intercept.
You need the slope and the y-intercept. And so I always identify my m and my b. The m is the slope, the b is the y-intercept. So what is my y-intercept and my slope, please, Irene?
Your slope is 1 and your y-intercept is 3.
Right. She says my slope is 1 and my y-intercept is 3. Now, I'm going to check that. I know my y-intercept is here. And then I'm going to notice I go down 1, that's negative 1, and I go left 1, it's another negative 1. So really it's negative 1 over negative 1. Are you sure that's positive 1? Why? Why? Yep. Because a negative divided by a negative is always a positive. Also, another way to look at it, when I'm checking my slope, I can do any 2 points that meet at a box. I don't need them to be written there. I can rise 1, run 1. Okay? We can also look at it and notice we read a graph from left to right. It's a positive slope, so it should be positive. Now, once I know my slope and my y-intercept, how do I write the equation, Callie?
You do y equals x plus 3.
X plus 3. Now, the only thing I'm missing here is my domain, because this does not go on and on and on forever in both directions. Okay? It does not go on and on forever there. So, what is my domain? Yes?
Your domain is if x is less than 0.
X is less than 0. So I take my point, I go down to the x-axis. On the x-axis, my domain is at 0. So that's going to be if x is less than 0. Okay, questions? Okay. All right, so let's go on to line B. I'll do it in a different color. Actually, I think let's go blue. So B, what am I going to say about B? What do I need to know? I see Luca. What's my M and my B?
M is 2, or 2 over 1.
Right, I'm going up 2, and I'm running 1. So it's 2 over 1. And my B, Luca?
B is negative 1.
Negative 1. So what is the equation, please, Torres? No, it's not x minus 1. 2x minus 1. And Shaylin, what is my restriction there?
Your restriction is x is greater than or equal to negative 1.
X is greater than or equal to negative 1. How did you know that it was equal to, as opposed to the other one, which is less than?
Because it's a closed circle.
Because it's a solid circle. Yes.
It's x is greater than or equal to 0.
Yeah.
Oh, yeah, not 1. Do you know why, Shaylin?
Because it's on 0.
0 on the x-axis, yes. Okay, so she was taking the y-intercept. Thank you for clarifying, Luca. It's if x is greater than or equal to 0. So, now we are left to write our piecewise function. We have all the information we need. It's going to be very easy. We know we write a y. Okay? We know we have to say y equals, and we need the big parenthesis. What is my first equation? Shaylin?
X plus 3.
X plus 3 if what restriction?
X is less than 0.
Okay, and the other one? Yes.
Y equals 2x minus 1.
I don't need y equals, so I've already written the y equals. What am I putting inside the 2x plus 1? Minus 1, sorry. Minus 1. And what's that restriction?
X is greater than or equal to 0.
Now, there's one more piece to this, and that's in the language. And that's in this word right here, function. So what are we talking about here? How am I going to show it as a function? Moreno. The f of x equals, so I don't need to rewrite it. Sorry, I'm getting sidetracked here. Okay, so the f of x, does that make sense? Okay, questions? Questions? All right, so that is how we write our piecewise function based on this. The next type of function is called a step function that we are going to go on to. And I'm going to use a piece of a video from eMath instruction. And here we go. We're going to look at it in terms of a word problem. Okay, yes, you're going to write this coordinate plane, not this one, the next one, down. And you can just start to why is he not going? Because I have so much technology happening, it's not working.
Just refresh it.
Yeah, but then I'm going to have to.
Try starting it over again.
Use that 2 for
this text, and then we're going to move on to the first true step function problem.
Okay, does everybody know what a y equals kind of equation looks like? Show me with your arm what it looks like. Right? It's a horizontal line. When you see y equals, it's a horizontal line.
Let's take a look.
First, he reviewed that.
So we're going to start actually with an applied example. Exercise 1 says an electrician works at a job site at a rate of $40 per hour or any portion of an hour. In other words, he will charge you $40 as soon as he comes up to the first hour, and then $40 for the second hour, etc. Letter A says graph the amount the electrician charges in dollars as a function of the number of hours that he works. See, this is kind of cool. Take a look at the scale. Right, just to make sure you get it, 20, 40, 60, 80, 100, 20, 40, 60, 80, 200. So these things are going by 20s. You can always mark that off if you need to. I'm going to mark it just for the first 100 so that we kind of get.
Okay, you should be drawing this. Draw the X and Y. Guys, you can't just listen. You got to write and draw. Pausing the recording, draw the coordinate plane, and label your axes. Charges versus hours worked. Okay, so now we're going to put an open circle at 0 hours at $40. Now, if the electrician has not worked for me, will I get charged?
No.
So that's why I'm putting that open circle. Does that make sense? Now remember, I am going to be charged all the way from 0 hours to 1 full hour. I'm going to be charged at a constant rate of $40. So up through and including 60 minutes. So I'm going to really, all I'm doing is drawing my line up to that first hour, and I'm going to put a solid line. I'm going to let him explain it. I think he can do a little bit better job.
For the entire first hour, what's going to happen is he's going to charge us $40. All right? Doesn't matter whether we're at a half an hour or 3/4 of an hour or a quarter of an hour, he's always going to be charging us $40. Then as soon as we get past 1 hour, he's going to start to charge us $80. So everywhere between 1 hour and 2 hours, the electrician is going to charge us $80, including all the way up to 2 hours. Remember, open circles mean that the point isn't really there, right? After 2 hours, he's going to lump on another $40. That's going to get us up to $120. All right? We're going to be paying $120 for every amount of time between 2 and 3 hours. Then he's going to lump on another $40. So we're going to be at $160 between 3 and 4 hours. And then he's going to lump on another $40, and we're going to be at $200 between 4 and 5 hours. You can probably tell why it's called a step function, right? It looks like we could literally step up this function. Okay?
All right. Now, why do you think it's in the piecewise? Why is this part of the piecewise family? Annabella.
Because it starts and it ends, and it starts, every single one has restrictions.
Okay. That's true. What is a piecewise function? Hi. Yeah. Come. Here. Oh, I am recording, so just grab it. Okay. So why is it called a piecewise function? Yes.
A piecewise function is a function defined by 2 or more equations. Each piece of the function applies to a different part of the
Okay. But in your words, in kid words, it's in pieces. So we've got ourselves a function here with pieces of a function, okay? So that's why it's in the piecewise unit. But this is a special kind. We call it a step function. Now, whenever they teach us something, we don't just, we basically have to use it. So what are we going to do to use this? The next question asks, how much do they charge for 3.5 hours? So we have to be able to read the step function and make sense of it. Who can tell me how much we're going to pay for 3.5 hours? Luca.
You're going to pay $160.
Right. And so we can
But if
see...
he says, how much does he charge for working 3.5 hours? Circle the point on your graph to show this answer. This is pretty easy. Here's 3.5 hours, right? And he charges 20, 40, 60, $160. There we go. $160, right? It almost doesn't seem fair, I'm sure, because he's charging $40 an hour, but we haven't hit 4 hours yet. Still, this is very common when you talk about contracting rates, because a contractor doesn't exactly know necessarily how long it's going to take him or her to finish the job. So for that first hour, you're going to pay a flat fee of $40, and then for the second hour, another $40. So it doesn't rise in a linear sense. It's constant, then jumps up to another constant, jumps up to another constant, etc.
Okay, so now, basically...
I'm going to clear this out. So write down whatever you need to. All right, here it goes.
Okay, that's the second part of the
Let's move
homework.
to the next exercise. Okay, so the first exercise...
Okay, now, the third part I think is going to be easier for me to describe, and let's just hope I can draw on it. Let's go back to the situation of the word problem. When do we see these types of situations? The electrician that charges $40 per hour, yeah.
Paying workers.
Paying workers, or have you ever been to like a parking lot? You go 1 minute into that 20 minutes and you pay for that entire 20 minutes or that entire hour. So in a parking lot, data. If you have a limit on your data, you go 1 minute, if you go 1/100th, 1,000th more than 10 gigabytes, if your data is maximum 10 gigabytes, you pay $15 for the next gigabyte. You don't get to pay a portion. So with cell phone data plans, we'll see stepwise functions. We'll see it with parking lots. Yes?
On that graph that he was showing us, so does that mean that, like, he adds $40 every hour, or every hour he, like, so for the first hour it's 40, but then for the second hour it's $80 for
Right.
$40?
Right. No.
So he's just adding
It's $40. That's why it's this. Notice it's the charge. The y-axis is for the charge. So for the second hour, if he charges $40 per hour, in the second hour, any point from 61 minutes to 120, you will end up paying $80 total.
So the open circle is just showing where the second part of it, like,
But it doesn't include that 60 minutes because it starts right at 61. Yes.
Since the electrician can just, he works like that, and every hour he works at, like, couldn't he just, like, not work very hard and still make, like, 100?
Yes, absolutely. But we're not going to get into any what ifs. We're just right here because you have a test to take today, okay? So we got to kind of keep it brief. I don't mean to cut you off. All right, we got one more problem to show you how to do, and that is when we go to this problem right here. Now, I'm going to go really quick. If you remember, we did part A last week. You know, when f of 2.7, which function am I using in this piecewise function? Which one are we using to evaluate it? Luca?
We're using the first one, or 2.
The first one that says 2. Can you see that? Oh, of course it stopped working now. All right. Let me try it one more time. Of course, it stopped working. Okay, so we're using that first one, which is 2. No, it's not working. Okay, I'm going to switch over to the smartboard. And why are we using that one of 2? Why are we using it as 2? Yes.
Because 2.7 is equal to 0.
Because 2.7 fits that top domain of 0 is less than x. So the ordered pair would end up being, I can't reach up there, but my ordered pair, if I'm doing the f of 2.7, we would say that the answer would be 2. Is that making sense to you guys? You remember that from last week? And if that were a point, I'd be doing 2 7/10, comma 2. Are you with me? So I'm going to skip that right now. And I'm actually going to talk about how to graph all of these functions here. Now remember, the f of x equals 2. What kind of line is that? Annabella? It's horizontal. That's almost the same thing. The f of x equals 2 is really the same thing as y equals 2. So if I go to, notice this is my x-axis. They're not showing the second and third quadrant. This is my x-axis. Okay, so if I go over here, here's my origin, and I count up 1, 2, my line would really kind of be going, I'm really in an awkward position, so I'm not making it straight, like this. Does everybody understand that? How to graph that first one, the f of x equals 2? The problem is we have domain restrictions. So the domain restrictions mean that we have boundaries. It's not going to go, and so where are my boundaries going to be on this line? Shaylin?
It has to be less than or equal to 0.
0 for the x-axis. So 0 on the x-axis, 0 on the x-axis is here. So that's where I'm starting. And will it be a solid or an open circle?
It will be solid.
Solid circle. And I'm going to go all the way up to what number
3.
on the x-axis?
3.
1, 2, 3, and go up. And that's going to be what kind of circle?
Open.
It's going to be an open circle. So I'm going to go here. Okay, I've done my first one. Yes.
Khan Academy also teaches this.
Okay. Everybody teaches it. It's a pretty universal concept. Okay, what are we doing for the next one? The next one, Ryan.
Well,
Loud so my recording can hear.
if the domain is between 3 and 5,
Let's first, before we start with the domain, let's just graph the line. The second line, where am I going to?
well, y, it says y equals 5.
Y equals 5, so where do I go to?
You go up 5 units.
5 units. 1, 2, 3, 4, 5. I'll go a different color, and I'll go 1, 2, 3, 4, 5. So now I'm here. This is my line, and I've got to really kind of think about my domain. Yes.
But that's 4 units, not 5.
1, 2, 3, 4. Oh, sorry. 1, 2, 3, 4. Sorry, I can't reach that. Sorry. 5. Okay, where's my domain taking me to? Where's my boundary line? Luca.
In between 3, so it would be a solid circle on 3.
So I'm counting over here. 1, 2, 3. Go up, it's going to be a solid circle. And the other boundary line over here, Zenzele, because I'm doing this one right now. What's the number? 5. On the x, it's saying x is between 3 and 5. So here's 1, 2, 3. And here is for 5. So what kind of circle will that be? Open circle, right? Oh. I don't know how to do that. So
If you pick up one thing, it'll automatically switch to the other.
I know. So I've got my solid circle. I've got an open circle here. And so my line is going to be on the 5 mark here. You with me?
Yeah.
Okay. This is my domain. There's 3, there's 5. Oh, did I go further? Okay. This is my domain. There we go. Sorry. All right. The next one. Can you guys see around me? Where are we going? Let me have Ethan.
Our first boundary line is 5.
I've already done this one. I don't want boundaries first. I want you to tell me where the line is. Where am I starting at?
Oh, you're starting?
Okay. Oh, you want to start with the boundaries. Okay. 5 where?
On the x-axis.
No. Okay. Where am I graphing this next equation? The boundaries are on the x-axis, but where do I go once I go over them? That's what I'm asking. Luca.
Is it 5, -5, -4?
Okay, so remember, I'm going to 5, -4. This is I like the way he put that. So this is really 5, -4. And the other one is what?
10,
10, -4. That was an interesting way to put it. So now we're, but where is it? Where is this line? How many units up, down, where?
Oh, it's 10.
Yes.
It's 5 units to the right and 4 units down.
4 units down on the y-axis. So I'm going to -1, -2, -3, -4. Then or if we went 5, -4. Is this going to be a solid or a open circle?
Solid.
Solid for that one. And then we're going to go all the way up to 10. 5, 6, 7, 8, 9, 10. Is it solid or open?
Solid.
Okay. And I draw the line. Now, is this a function? Is this a function? Is there what's the true definition of a function? Ryan?
Well, a function, it has to pass a vertical line test. So if you were to run a vertical line through it, no 2 points can be.
So we're running our vertical line test. There's no 2 points that overlap. It's okay because this one's hollow, this one's solid. And now basically we have completed graphing the step function. Yes?
When you said since that one's hollow and that one's
Solid.
yeah, what if they were both solid? It wouldn't make a difference.
It wouldn't necessarily be a function. Because if you're looking at distance and time, you can't travel two distances at the same rate, two different distances at the same rate in the same amount of time. Or how about two distances at the same speed? If you had speed and distance, do you understand? It wouldn't be a function. It would be a situation that was impossible. All right, now the last two questions are state the domain. Now, if you notice, my domain really kind of starts here. And where does it end? I'm using x's from every single one of these. Like this, if I pulled this point, it would use an x. If I pulled this point, it would use one of my x's. There's no x to use in any of the graphs. So what is my boundary limit for Annabella?
0 is less than or equal to x.
Perfect. We're going to use an in-between. 0 is less than or equal to x, which is less than or equal to 10. Now, my range is a little bit different. You're going to put it into braces. And here's the thing. See, I'm not using all this continuous space here. Is that making sense? So I have very specifics. My range is only my 2, my 5, and my -4, because it only goes through the y at those places. 2, 5, and -4. 2, 5, and -4, and we close our braces. Okay, questions? Yeah.
Where'd that 2 come from?
Up here, because look, at 2. These are the only y's, only here. This is 2, I'm using 5, and I'm using -4.
Oh.
Okay, only my y's there. It doesn't use all this in-between space. Sorry about that.
What's known as a piecewise function. We'll stay in red for the moment. All right. What's known as a piecewise function.
So, questions? You okay? Okay, let's take our quiz, our test.
Oh boy.
Good, it cleared it for me. Awesome. Okay. Pause the recording. That's it. Tonight you're doing page 223, 23 through 36 all.